Hey everyone, welcome to today's explainer for June 4th, 2026. I am absolutely thrilled you're here because honestly, we're going to tackle something today that is a total game changer for how you write database queries. We're demystifying SQL Analytic Functions in the Oracle AI Database 26AI. You know, if you've ever found yourself pulling your hair out writing these incredibly convoluted, painfully slow SQL statements just to get a simple cumulative total or a ranking, well, you are in the exact right place. We're going to take that complex syntax and turn it into intuitive, visual concepts. So let's jump right in.
All right, picture this, the classic database developer's dilemma. You've got a table packed full of employees, right? And you just want to know the average salary for their department. Easy enough, but the very second you throw in a standard SQL group by clause, poof, all those vital row-level details, like the employee's actual name and their individual salary, they just vanish. You're left staring at grouped department data. You aggregated it, sure, but you completely lost the context. So the big question is, how on earth do you calculate an aggregate without losing that individual row data?
To figure that out, here's our roadmap for today. We're going beyond basic aggregation, checking out the magic over clause, ranking data, mastering the sliding window, doing a little time travel with lead and lag, and finishing up with a real-world scenario. Section 1. Beyond basic aggregation.
So here's the magic key that actually solves our problem. Right from the Oracle reference manual, analytic functions compute an aggregate value based on a group of rows. But, and this is absolutely crucial, they return multiple rows for each group. That group of rows, it's called a window. Basically, this means you can finally have your cake and eat it too. You get to pull the departmental average and see it sitting right next to the individual employee's name on the exact same row.
Let's dive a bit deeper into this comparison, because honestly, it's the foundation of everything we're doing today. Standard aggregate functions. They return exactly one row per group. That is your classic group by. But analytic functions, they return multiple rows per group. They do all the heavy lifting of the aggregate, but they don't crush your results set down into nothing. Literally every single row that went into the calculation comes right back out, just beautifully appended with that brand new calculated value.
Moving right along to Section 2, the magic over clause.
Okay, meet the over clause. When you tack over onto a function, it tells the database that this function operates on a query result set. Now, what's genuinely fascinating here is the order of operations. The Oracle documentation specifically notes that analytic functions are the very last set of operations performed in a query. Well, except for the final order by. That means all your joins, your where clauses, the group by, the having clauses, the whole shebang. They are 100% finished before the analytic function even starts thinking about doing its math. Then, the partition by splits your data up into logical groups, and the order by dictates exactly how things sequence within those groups.
Which brings us to Section 3, ranking data, resolving ties.
You know, Oracle actually gives us 3 distinct ways to assign order numbers starting at 1, and the rules are super crisp. First up, we've got rank. Now, rank gives the same rank to identical values, but, and here's the catch, the rank after a tie adds the number of tied values. Basically, it skips numbers. Then we have dense underscore rank. This one also gives the same rank to identical values, but the rank right after a set of ties is always exactly one more than the tied value. No skipping allowed. It's completely consecutive. And finally, row underscore number. Man, this function is ruthless. It assigns unique consecutive values no matter what. If there's a tie, it doesn't care. It just assigns the next number based on whatever order it processed the row.
This really brings it to life. Let's walk through these sample HR salaries. Our top earner is bringing in $9,000, so they get a 1 across the board, obviously. But check out the next 2 employees. They both make $4,800. With rank and dense rank, they tie for second place, so they both get a 2. But remember row number? It just pushes right through, handing out a 2 and a 3. Now look closely at the person making $4,200. Because 2 people tied for second earlier, rank completely skips the number 3 and hands them a 4. Dense rank, though, it stays strictly consecutive, so they get a 3. And row number just keeps marching along its unique sequence, landing on a 4. Truly understanding this little nuance is going to save you so many reporting headaches down the road.
Let's keep the momentum going with Section 4, Mastering the Sliding Window.
Okay, bear with me on this syntax. I know, it looks like a total mouthful. Range between unbounded preceding and current row. But here's the secret. This is actually the default windowing clause. When you use certain analytic functions and you don't explicitly specify the window, this is exactly what Oracle uses behind the scenes.
All it means is that for every single row the function evaluates, it builds a specific frame of data. It's basically saying, hey, start at the very beginning of my partition, that's the unbounded preceding part, and calculate all the way down to the exact row I am sitting on right now.
It really helps to think of it as a tangible physical frame moving down a spreadsheet. That is your sliding window. Step 1, the database starts at the very first row of your partition. Step 2, it expands that window down to your current row. Step 3, it performs whatever calculation you asked for, like, say, a cumulative sum. And Step 4, it slides the window down one row, the frame expands to include that new row, and it repeats the math. It's brilliant. This is exactly how you effortlessly create a running total that just grows row by row without writing any clunky loops or cursors.
All right, Section 5, Time Travel, Lead and Lag.
So the really cool thing here is that lead and lag literally let you peek into the future or look back into the past of your data. Lead accesses a row at a physical offset beyond your current position. Imagine you're trying to compare today's sales with tomorrow's sales, but you want them on the exact same row. Lead grabs that for you effortlessly. Lag, on the flip side, accesses a row at a given offset prior to your current position. If you want to figure out month-over-month growth, just use lag to pull last month's number right next to this month's number. It completely 100% eliminates the need to join a table to itself just to compare sequential rows. It is a total lifesaver.
Let's put this into practice. Section 6, Real-World Scenario, Top Earners.
Here's our mission. We need an inner end report. We want to identify the absolute highest paid employees inside of each specific department. And we don't just want the maximum salary number, right? We want the actual employee's name attached to it. To pull this off, we are going to use the ROW_number function to grab this precise subset of rows.
Now watch how the partition by goes to work here. We've ordered our employees by their salary descending. For Department 60, Hunold makes $9,000, so he gets row number 1. Ernst gets 2, Austin gets 3. Simple enough. But look what happens the second we reach Department 90. Because we used partition by department_ID in our over clause, the database knows to immediately reset the window. The sequence completely restarts. So King, who is making $24,000 over in Department 90, gets a brand new row number 1. To actually finish our real-world goal, all we have to do is wrap this query in a quick outer select statement and just say where row number equals 1. It is elegant, it is hyper-efficient, and it is incredibly powerful.
We have covered some serious ground today. We journeyed through the magic of the over clause. We resolved those tricky ties with ranking functions. We mastered the sliding window, and we even did some time traveling with lead and lag. By returning multiple rows per group instead of just crushing your data down, you really do unlock a completely new level of analysis. So here is my final question to you. How are you going to optimize your SQL queries tomorrow using analytic functions? Thank you so much for focusing in with me on this explainer today, and hey, keep exploring your data.